So we want to work out this integral then between 0 and pi over 2 using the trapezium rule with 7 ordinates to 3 decimal places. First thing to do is get h. So here h equals then b minus a. Pi over 2 minus 0 is pi over 2, so I'll just write that in. Over the number of intervals, there's 7 ordinates, so there's 6 intervals. So pi over 2 over 6 is pi over 12. So that's the value of h. So we need the x's now, the ordinates. So we're going to go with 7 ordinates, start from x0 then, x1 up to x6. There we go. Let's just work out what these are. So if the first one is 0 and the last one is pi over 6, we can write that as 6 pi over 12 and we can write that as 0. So we can see clearly that the intervals are pi over 12, pi over 12. So let's just add pi over 12 each time then. And 5 pi over 12 in here. There we go. Now we need the y, the associated y values. So just quickly put them in here. There we go. Now, y0, I'm going to label this f of x just to save some time. This thing here, the integrand here. So this will be f of 0. This will be f of pi over 12. This will be f of 2 pi over 12. F of 3 pi over 12. And all the way down, basically, in the same manner. And the last one is f of 6 pi over 12. So we need to type them out. The first one is f0, so put in 0 here. Cos 0 is 1, and the square root of 1 is 1. So that's nice and easy to start with. And then we need pi over 12 in here. Square root of cos pi over 12, isn't it? So let's get our calculator. Make sure you're in radians mode, which we are. We want the square root of cos, and then we want a bracket pi, pi divided by 12. There we go, close the bracket. So that's what we want for the first term. Let's do it, it's to 3dp, so we need to work to 5dp to allow sufficient margin of error. So 98282 is next, we round the 1 up to a 2. 98282, 0.98282. Now we do 2 pi over 12, and all we need to do here, 9.8282, yeah. All we need to do now is just go toggle back and put a 2 in. 2 pi over 12. 93060, 93060, yeah, agreed. 0.93060. Then the third one, next one. So let's go back here, change that to 203. 840889, but there's a 6, so it rounds up to 90, so it's 84090. 84090. Next one, the 4. And we can check it as we go. So the 4, that one's okay. 4 pi over 12. We get 70711. 70711. Then the 5 pi over 12. Just toggle back again. All the templates fine other than changing the 4 to a 5, isn't it? 50874. 50874. And then the last value, 6 pi over 12, let's put that in the calculator just to make sure we're happy. We're all happy with this. I'll put a 6 in, and we get 0. Because cos 90, pi over 2 is 90, cos 90 is 0, and the square root of 0 is 0. So that's what we've got then. So, what have we got then? I will be, so let's use the formula h over 2. So it's pi over 12 over 2 is pi over 24. Open bracket. The first and the last, so that'll be 1 plus 0. Plus 2 times all the middle terms, isn't it? Here's the middle terms here, everything in between. So these 5. So it's all these, and we add them, and we double them. So what we could do, save us just to save room here, we could just type up the sum there, couldn't we? Just add them, because we've got them all in a nice row here, and put that number in there. So let's do that, shall we? On this one, because there's rather a lot of things to write out again. 98282, 0.98282, plus 0.93060. 3060 plus 84090, 0.84090 plus 70711, 0.70711 plus 50874, 0.50874. So I'm just to be fussy, I'm going to just go back and visually just check everything's entered correctly. Because if we do this once, we should be alright. 98282, 98282, 93060, yeah, that's fine. 84090, yeah. 70711, yeah. And 50874, yeah, everything's fine. 3.97017. 3.97017. There we go. Close the bracket for the two lots of all these. And then we close the brace at the end. So it's pi over 24 times all this number here. So let's get our calculator. Leave that number there. Times it by 2 equals. Now we add 1. So let's just do it like so. We get that number. Times by pi and divide by 24. So we'll times it by pi and equals, and then we divide it by 24, so divided by 24. We get 1.170 to 3dp, 1.170, and that was the 3 decimal places.